Hi, everyone. Thank you again for joining and welcome. So let me spend a little bit time on these layers and what you are seeing over here so that you can follow along with me. So here in the layers, I have quite a few pre-created layers. So you would see that I have something that's called the base layer. That's very similar to the layer that I just gave you the demo of. And then we build on top, right? So you will see that I have various scenarios. I know it is grayed out and that's why I'm highlighting it, but it's essentially showing you scenario number 1. Then I have scenario 2, 3, 4, and so on. Today, I'm going to cover 4 scenarios in a single region design and 2 scenarios or 3 scenarios, I think, in the multi-region design. All right. And we build upon, so the idea is the base layer is really what works out of the box, right? What you get in a typical hub and spoke architecture. And as we build on scenarios, we look at the why behind why do we need an Azure firewall? Why do we need a route server? Why do we need an NVA network virtual appliance? So I'll build upon the scenarios, okay? And each scenario, there is a why. So just keep, if you are presenting this, I have, so let's say that you're presenting this. In each scenario, I have presenters notes over here. So be sure to check that out if you're using this to run your own envisioning session. And then lastly, there is no networking discussion without IPs. So I have this optional IP layer. So if you're having a conversation with your customers and you need to talk IPs, you can turn this on. For most part of this, I'm going to leave that off just to keep our diagrams uncluttered. All right, so let's dive into scenario number 1. So scenario number 1 is default hub and spoke architecture. So what that means is we'll 3 different type of flows. One is the green flow, the second one is the orange one, and the third one is the blue one. All right, so just so you can keep the focus as I move around the mouse, we'll start, they're all color coded, so I'll start with the green flow. So what the green flow is showing in a hub and spoke architecture is that the spoke can talk, this spoke at the top can talk to this branch. It has IP connectivity. By all means, if there is a firewall or if there is even an OS level firewall, it would prevent that flow from happening. But we're talking strictly routing. From a routing perspective, that flow will work. Now, one important thing as you look at a hub spoke architecture is there is these 2 VPN gateways and express route gateways and the gateway subnet. It's very important to, when you plan out your gateway subnet, even though you could have a small subnet like a /29, you want to make it a little bit bigger, a 27 or a 26 to accommodate most of the scenarios, right? And like I said, unless you're a service provider in Azure, you should carve up, you should put a /16 in your hub if you have the IP space available, and give your gateway subnet a good size gateway subnet. Now, other thing to keep in mind is this VNet peering. There are a lot of settings that happen on that VNet peering that are important for this flow to work. So that's the green flow, spoke to branch. Now let's look at these 2 orange flows. The orange flows are between a site-to-site connected branch and another site-to-site connected branch, right? So these 2, the first 2 are the site-to-site connected branches. So as you see in this diagram, it hairpins off of this gateway, and the same with the point to site. Point to site is very similar to a client VPN. And then these two, the last two, are express route connected branches. So this orange flow here is showing you that between two express route connected branches, we're using the global reach. Again, I have AVS listed in this scenario, but for all practical purposes, think of this as an AVS, as an express route connected branch. And then lastly, the blue flow over here is showing egress from Azure. So if this VM were to egress from Azure, it uses the instance level IP if it is assigned to it, or in default outbound IP. And we'll go into a lot more depth in for outbound in Azure in scenario number 4. Now here in AVS, we also give you a local egress point. So that's what this is demonstrating. So now you're probably thinking, this is great. So what are some of the routing considerations in this design? So let's toggle the next layer. So again, when I show these flows, unless it is red, it is demonstrated as a working flow. So let's look at the routing scenario, routing considerations. So in this hub and spoke design, out of the box, the flows that are shown in this diagram, in this red animated flows, those don't work out of the box. So at the top, spoke cannot talk to spoke by design. And then a VPN connected branch, which is the first one, cannot talk to an express route connected branch. So that's what this one is showing. So, and it kind of gives it away. If you want that connectivity, I have a little light bulb over here. What do you need to do to get that connectivity? So let's look at the solution. So we'll look at this solution first, and then we will look at this solution to get these red flows working. So to get the top red flow working, we can introduce an Azure firewall. So what Azure Firewall allows you to do is it gives you, not only does it give you the spoke-to-spoke connectivity, but you can funnel all of your internet-bound traffic through the Azure Firewall. Now, there are two important elements, configuration elements that I want to call it out. Again, this is about envisioning, but you will see that in every scenario, I write a few things to think about if your flows are not working. So in this design, it is very important that when you create a UDR, a user-defined route, that a 0/0 quad 0 route pointing to the firewall, that you set your propagate default route setting to yes. And for that, the reason for that is that you still want your spoke to branch traffic to kind of bypass that firewall and have symmetric routing, right? So be sure to check out the notes that I have on the left-hand side of the screen if something is not working for you. Now let's see if there is another way to solve the same the solution to that same flow. The other way you can do it is instead of the NVA, instead of the firewall, you can put an NVA in the same similar placement. So essentially, you still point your quad 0 route to NVA, and it will give you the spoke to spoke and also the internet connectivity. Now, anytime you bring an NVA in the mix, I want to say two things. One is, of course, you need IP forwarding turned on at the OS level, as well as you could do it on the NIC on the NVA. But more importantly, the high availability of an NVA, we have a whole session on high availability of the NVA, so be sure to join that one. In this one, I only have one NVA demonstrated, but we'll show you how to do a best practice high availability design as well. And now before I end scenario number 1, I want to show you a full design so you can see all of the working flows, right? So we can put either a firewall or an NVA in this picture, but this is fully done using platform as a service, and all of these flows will work. So let's see what drives the need for scenario number 2. Remember, in this routing consideration, I mentioned these two bottom flows. That's what scenario number 2 would show us how to solve that flow. So if we go to scenario number 2, and there is quite a bit to see over here, so I'll zoom in a little bit here. In this scenario, what we did is we put in an Azure route server in the middle. And essentially, you can see based on the bottom green flow that it's not in the data path. Essentially, what route server does is it exchanges the routes between your VPN gateway and the express route gateway. So you get that VPN ER transit. And then remember to have the branch to branch toggle turned on when you deploy the route server. And of course, you need a route server gets deployed in its own route server subnet. There is a corner case with route server. If I have time, I will go into the details of that. But for now, let's move on to the next scenario, which is scenario number 3. So what's driving scenario number 3? So let's say that your security team comes in and says, we need everything to go, all of the traffic to go through the NBA. Or if you have a regulatory need to funnel everything to a secure appliance that you've been using. And that's what drives the need for scenario number 3. So in scenario number 3, we are introducing, and you'll see at the bottom, I have presenters notes where the requirement for scenario number 3 is you want to funnel everything through all traffic via NVA, right? So in this scenario, you will see that NVA gets placed in the NVA subnet. It has an eBGP peering with the route server. And of course, in the previous scenario, we saw that route server had IBGP peerings with VPN and ER gateway, right? So that's all. So that's how the NVA peers with the route server, and be sure to peer your NVA with both of the route servers, right? So now how does the traffic flow when we have the NVA deployed in this scenario? So let's look at first we will look at the north-south traffic flows, and then we'll look at east-west, all right? So north-south traffic flow, let's light up that layer here. So there is a lot to see over here. So I will pause for a second till eyes get situated with the different items that you see on the screen. But basically, what we're doing is north-south, and in this particular diagram, the terminology north-south means traffic going to the internet. So essentially, this NVA is advertising a quad 0 route, which in turn gets advertised down towards your express route connected branches, or if you're using BGP over IPsec, it gets advertised over that route over that tunnel as well. Now, when you add, of course, you don't have to accept those routes if you don't want to in your headquarter branch, for example. But in this scenario, it's showing you what's possible, right? So this pink flows are showing that your express route connected branch would reach the internet. Similarly, if you're site-to-site VPN, that branch can reach the internet through the NVA that is deployed in Azure. And of course, this spoke can reach the internet through the NVA. A few things to call out. Like I said, in every design, if you scroll to the left, I'll call out some things to be aware of. Is that when you are running BGP over IPsec and you advertise a quad 0 route, you want to split that route into two smaller routes so that you can advertise them down. Okay, this is documented in our FAQ. But I ran into this with a customer, so I have put it here just to show it here. Now, as I mentioned before, anytime you drop an NVA, it is very important to preserve the flow symmetry. So it is important that you look at the settings that are done on your VNet peering and also on the gateway subnet. If you put a gateway subnet route table, that helps you preserve the flow symmetry. It becomes more important in the east-west flows than the north-south flows. So we'll go to that next. I just want to make sure in the north-south flows I'm not missing any important point to call out. Yeah, I think we got this. Yeah, so in the east-west flows, so let's of course you want to uncheck the previous layer when you toggle the next. Let me just have my thing to 42% so you can see everything on my screen. So I will warn you that this layer goes into level 300 of Azure networking. There is a lot to see. But it's really, if you think about it, if we know the use case, if we remember the use case for this, is we want to attract, we want to funnel everything through this central NVA. So you can see that all of our flows are now funneling through the NVA. And the way we do that is, again, by having a gateway subnet route table to preserve the flow symmetry, and then a quad 0 route over here on the VNet, on the spoke subnets, where you would point that to the NVA. All right, so two important things. Yes.
Quick time check, 10 minutes left for your session.
Okay, thank you. Thank you, David. All right, and so with that, I'm moving on to a smaller case where we'll turn off so east-west. Let me just finish my thought here on the east-west. You can see that these flows will not go through the NVA. And the reason being that they get hairpinned through the VPN gateway over here. Now, there is an excellent article written by Daniel for ER to ER through the NVA, and that's what this 10/8 is showing you. So essentially what we're doing is to force that traffic, instead of going through global reach, go through the NVA, we're advertising a 10/8. Again, it's a summary route in my design, but it would vary according to your IP scheme. So be sure to check that out, but this is possible. And then let's move on. So I have another small case with SD-WAN. You could do the same thing with SD-WAN, sort of advertise your SD-WAN routes down this way. And then let's look at the outbound flows real quick. In Azure, outbound is tricky. In other words, if you are used to funneling everything through like a single firewall in Azure, you get a lot of different options. So I'm going to highlight a few outbound options for you. As you can see, you can egress using a random IP, an instance level IP, Azure firewall, load balancer, or a NAT gateway. Of course, you cannot egress through the app gateway. And then you get inbound flows. You can come in using various, you have various options. But the challenge is that you have to be aware of is when you club these services together, and I'll show you an example of this one. So we'll follow this red flow where I was working with a AKS Azure Kubernetes Service customer. And if you are coming in, so the dashed line is showing incoming traffic and the dotted is the return flow. So what happens is if your incoming traffic comes through the external load balancer and you have a quad zero through the firewall, that flow breaks. There's an Azure documentation link on how to solve this. So be aware that if you're clubbing some of these services together, that this can happen. And then of course, this is the one with the app gateway is a little happier green flow because layer 7 proxy, it terminates the connection and the return traffic sort of goes back where it came from. So that's a happier flow. And then lastly, there is a corner case. If you have an internal LB, be sure to have a NAT gateway that gets for your egress traffic, right? So if you have a VM that doesn't have an instance level IP and it's behind an internal load balancer, it needs a way to egress, right? So be sure to club that with a NAT gateway. Now
So
this is a multi-region design, a very classic multi-region design. You can think of this as individual region that we have done, right? So that's this design is called a bow tie design or a crisscross design. And in here also I have the optional IP layer. And in this design, let me just go over the different flows, the default flows in the crisscross design. I will call out that I'm using express route bow tie, but I worked with a customer where we did a bow tie with site to site. So we were running BGP over IPsec, and you can also do a bow tie design that way. Or you could do a VP express route with VPN failover. But for this one, we're going to focus on the crisscross design. So let's look at how the flows would work in this design. So these are the inter-region flows. So spoke 1 on region 1 going to spoke 3. That's what this is demonstrating, the inter-region flows. And then it's also demonstrating in the next layer, we're showing how this spoke, for example, will talk to this branch. Okay, so these are really envisioning the different flows. And then some of the considerations, I want to call this out, that in the hub and spoke classic bow tie design, um, you will see that Azure will always ECMP the traffic across both of these connections. So this could potentially add latency to your deployment. So the reason this is marked red is not because they're not available, they're just something to consider. And of course, you can peer this spoke with this spoke, but that would add a lot more peerings between the spokes. So another way to design this is using the AZFW. Heather has written a fantastic blog on this. I call this Heather's scenario. Basically, what we're doing is to prevent this routing behavior of going hairpinning all the way back to the MSEE, right? This behavior. So we're setting the stage for this Heather's scenario, I call it, where we drop an Azure firewall, just like how we did in the single region scenario, and we influence the spoke to spoke routing behavior by having a route table in the firewall subnet pointing to these remote spokes. So in this firewall subnet on the left hand side, we would we'll have a UDR pointing to the remote spokes, and you get this green flow, which leverages the VNet peering instead of hairpinning back to the MSEEs. So pretty nicely solved that more optimal design here. Now, while this is a great design, this still involves manual UDRs. So this leads us to our final scenario, which is, I will tell you, this goes into level 500 of Azure networking. There is a lot to see over here, but basically what this does is it allows you to dynamically learn the routes. So this would look quite familiar to you from our previous NVA design, where where we paired our NVA with the route server. However, what this scenario is adding is two things. We are leveraging VXLAN to do an eBGP peering between the two NVAs to exchange the routes. So essentially, we're doing layer 2 over layer 3. And this NVA on the left peers with the NVA on the right to exchange the routes, so we don't need the manual UDRs. And if you want to see how all of that is done, you can turn on this VXLAN captures layer, really detailed view of what's happening behind the scenes. The other thing, just want to call out, I know I'm nearing the end of my side of the presentation, but be sure that you have an NVA that's capable of VXLAN for this design, and that on the MTU will have to be changed appropriately. And again, this keep a growth mindset, right? As new scenarios come up, be sure to check it out, and we'll add another layer.